ScopeSim includes built-in point spread function models as part of its instrument packages. If you want to use a custom PSF instead, TipTop provides a straightforward way to generate one. In this tutorial, we'll generate 2 point spread functions with different observing conditions and use them directly in a ScopeSim simulation. We'll begin by opening TipTop in our browser. You'll find the link in the video description. For the instrument, we'll select Mikado SCAO. Let's go through the simulation parameters. First are the telescope parameters. Here we can specify the telescope's zenith angle, the field of view, and the pixel scale. For Mikado, the pixel scale is already set to its native value of 4 milliarcseconds per pixel. We'll leave the zenith angle unchanged and reduce the field of view to 1024 pixels per side. Next we have the atmospheric parameters. If you select one of the predefined quality levels, the corresponding atmospheric seeing is filled automatically. For the first simulation, we'll choose Q1, representing excellent observing conditions. Alternatively, you can also specify the seeing manually. The source position specifies where within the field the PSF is evaluated. We will keep the source on axis and use the K-band for this example. Now we can run the simulation. TipTop writes the generated PSF to a FITS file. It's a good idea to rename the file right away, so it won't be overwritten and you'll still know what it represents. Before moving on, let's generate a second PSF with different observing conditions. This time we'll reduce the field of view to 512 pixels and choose median atmospheric conditions. Notice that this not only updates the seeing value, but also the zenith angle. We switch to the J-band and apply an offset of 10 arcseconds off-axis. As before, it's a good idea to rename the file right away. Now let's use these custom point spread functions in a ScopeSim simulation. For this we move to Python. I've already copied both PSF files into my project folder. After importing ScopeSim and ScopeSim templates, we'll create our source. In this example, we will use a cluster in the Large Magellanic Cloud with a total mass of 3000 solar masses, a distance of 50 kiloparsec, and a core radius of 0.3 parsec. Next we define Mikado as our instrument, with SCAO and a 4 milliarcsecond imaging mode. Before changing anything, let's inspect the instrument settings. We simply type Mikado, settings, and execute the cell. Under the Relay Optics section, we can see the default PSF configuration used by ScopeSim for Mikado. Let's first run the simulation using these default settings and display the resulting image. Now we want to replace the default PSF with the first one we generated in TipTop. First we define the path to our PSF file. Then in the instrument definition, we add the properties dictionary and assign our PSF file to the Relay Optics PSF file property. If we inspect the settings again, we can see that ScopeSim is now using our custom PSF. Running the simulation again shows the effect of the new point spread function. Let's repeat the same procedure using the second point spread function we generated. The median quality J-band PSF evaluated 10 arcseconds off-axis and compare the result. And that's all there is to it. With just a few additional lines, ScopeSim can use any point spread function generated with TipTop.